Hey guys, I just wanted to go over real quickly the lab we were doing today and make sure we're fairly comfortable with the math, because I do expect you to come in with a graph on Monday for this data. So we have iron plus 3 reacting with the potassium thiocyanate, which is the SCN. So again, we're just looking at a net ionic here. And it's going to form something we really haven't talked about before, which is a complex ion, which just means this guy, okay? This guy starts as a kind of a yellowy orange. This guy is clear. And this guy, when it's in a high enough concentration, is actually a deep red, almost a blood red. We didn't get to really see that much, but that's okay. So just so we can kind of get an idea, we were measuring this guy's color, okay? Because remember, we were looking at that 430 range, which is around the blue range. And blue and red are kind of those opposites in that spectrum, if we remember what that's doing and what's going on there. Okay, but let's talk about the actual math we have to do here. So in this reaction, you added 8 milliliters to begin with, okay, of our iron nitrate. You added 2 milliliters of our potassium thiocyanate. And again, what we were measuring was our iron thiocyanate ion. So we need to get to this guy. We have to know what's going on. Remember, what we're trying to do is create a graph of concentration versus absorbency. Okay, well, concentration of who? This is concentration of the Fe SCN ion. Okay, which means we have to actually get to this guy and know its concentration. So how do we do that? Well, first off, this guy was 0.2 molar, and this guy was 0.0002 molar. And both with 3 proper sig figs there all the way through. Okay, it's a limiting reaction problem. So we have to work through it that way. First and foremost, when we're doing stoichiometry, we have to get into moles. So remember our molarity, we'll do of the iron to begin with, is moles per liter. Okay, well, we only used 8 milliliters, so times 0.008 liters to actually get that number. So 0.2 times 0.008 gives us a mole value of 0.0016 moles of iron. Okay, and if we take that to our iron thiocyanate, it's a 1-to-1 ratio. For every 1 mole of iron, we get 1 mole of the iron thiocyanate. Okay, which means we end up with this reaction, 0.0016 moles of the Fe SCN. Okay, now we have to do it for the other guy. Same thing. 0.0002 molar, and hopefully we actually see the math here and we automatically know who's going to be our limiting reaction, but that's okay. We'll just go ahead and do it. Per liter times 0.002 liters, because we have 2 milliliters. And that's going to give us a total of 4 times 10 to the negative 5th moles of our thionate ion. Okay, from here it's a 1-to-1 ratio again. Okay, and that's going to give us 4 times 10 to the negative 5th moles for our iron thiocyanate. Okay, so obviously we can see which one's bigger. We've got 1.6 times 10 to the negative 3rd to put it into the same notation, and 4.0 times 10 to the negative 5th. So definitely have our potassium thiocyanate as our limiting reaction, which we did that actually on purpose for this reaction. That's why we use such a small value. Here's the nice thing. You can assume he is our limiting reactant for all 5 of our reference reactions. That way you don't have to continue doing this. You can just do this piece of it. Okay, so again, we're looking for, whoops, sorry, not sure what just happened. We're looking for the molarity of this guy. Oh, and it changed colors on me too. Fun. Anyways, we're looking for the molarity of the potassium thiocyanate. So once we have the moles, 4 times 10 to the negative 5th moles of the iron thiocyanate, SCN plus 2, we want to find molarity. Well, remember, molarity is moles over liters. Okay. Our final volume is the combination of both of these, so 10.00 liters to be precise. Actually, sorry, not liters, milliliters So 0.0100 liters, so that we actually have that correct number here. Okay, and that's going to give us 4.00 times 10 to the negative third molar. And apologize for the sig figs, I'm kind of all over the place, but give you an idea, this guy should have 3 sig figs. I'm not sure what that extra 0 is here, so 3 sig figs. 3 sig figs, all of your liter measurements should be 3 sig figs. So we should be keeping 3 sig figs all the way through. So kind of ignore some of the random sig figs throughout here. So once we have our molarity for each one of our reference solutions, so you'll do this 5 times for each reference solution, you'll get your molarity of the iron thiocyanate ion, and you will create your graph of those concentrations, those molarities of the iron thiocyanate against the absorbances you collected. Okay, and 0, 0 does need to be one of them, don't forget that. And then you should have your other 5 references, whatever they are. You're going to graph those with Excel instead of using your hand, hence the reason that looks awful. And you're going to get your y equals mx plus b. Once you have that, you're going to be done for the weekend. One person at least in your group needs to create this graph and bring it in with you on Monday, and we'll finish the lab from there. Hopefully this helps, guys. If you have questions, let me know. Thanks.